Hi everyone, I'm back in the next example. We're going to be finding the midpoint between two coordinates. So basically it's the midpoint of the segment that would be joining 2 points. And so this is the formula. This is an ordered pair right here. These are the parentheses. This is the overall x coordinate, and this is the overall y coordinate. And basically how we find the midpoint is we just average the two x coordinates and average the two y coordinates. And you can see here that this is just a regular mean. We're adding the two coordinates together and dividing by 2. We're adding the two y coordinates and dividing by 2. And you can see there's this comma separating the two x coordinates. So this is just an ordered pair. And to find the midpoint, we just average the coordinates. So let's go ahead and do that. So again, just make a quick sketch here of our graph. So we have -3, -2, it would be right here. Again, that's if we go with a scale of 1 in both directions. And then 0, 4 is right here. And we're trying to find the midpoint of the segment that would connect these 2 points. Now it looks like the midpoint is, I don't know, somewhere right here. But it's hard to guess looking at the graph. Let's actually calculate it. So the midpoint, x comma y, is going to be the average of the two x coordinates. So -3 plus 0 divided by 2. And the average of the two y coordinates, -2 plus 4 divided by 2. So this here gives me -3/2. And I know everyone's probably dying to write that as -1.5. -3/2 is an exact answer to infinitely many decimal places. This number represents the decimal, -1.50000000 forever, whereas -1.5 represents the approximation to one decimal place. Okay, so fractions are always better, and improper fractions, it's always unfortunate that that's the name that they got, but improper fractions are the better way to go. Over here we have 2 divided by 2, which is 1. And so we have -1.5, 1. So it's actually, the midpoint's right here. And maybe that looks more like the middle for some of you. Let's see. This distance and this distance, yeah, I would agree with that. Not saying that my graph was extremely accurate, but it does look like the midpoint at -3/2, 1. So that's my answer. Now, a lot of what we're going to do here is going to seem unrelated. It's just going to seem like a lot of topics. And that really is the truth about pre-calculus. There's a lot of skills, discrete skill sets that you need to know and understand before you can get to calculus. And so we're just going to go through all of those skill sets, even if they don't connect to one another right now. When you get to calculus, you will see that connection. You will see why we needed to be able to do all these things. Because in order to do all the things you need to do in calculus and really understand calculus, you have to have a strong foundation of algebra behind you. All right, so let's sketch this graph of y equals x squared minus 4. So if you're familiar with the families of functions, you know that this is a quadratic function. But let's say you did not know what kind of equation this was and you wanted to graph it. The first line of defense with graphing is to set up a table of values. Just start plotting points on the graph and see what it looks like. So I like to start with 0 because that's the easiest to plug in. So when I plug 0 into here for x, I get 0 squared minus 4, which is -4. When I plug in 1, I get 1 squared minus 4, which is 1 minus 4, which is -3. When I plug in 2, I get 2 squared minus 4, which is 0. When I plug in 3, I get 3 squared minus 4, which is 9 minus 4 is 5. Then when I plug in -1, negative 1 squared minus 4, negative 1 squared is positive 1. Negative 1 times negative 1. So negative 1 squared is negative 1 times negative 1, and a negative times a negative is a positive 1. So it's important that if you are going to use your calculator to do something like this, that you make sure that any negative numbers are in parentheses before you square them. If you put this into your calculator, you will get negative 1. And the reason being, the calculator knows the order of operations. Here it's saying, let's do 1 times 1, because the exponent's only talking to this 1, so we have 1 times 1, which is 1, and then we multiply it by this negative, which gives me negative 1. So order of operations says do exponents first. 1 squared is positive 1, times this negative 1 gives me a negative 1. So when we're substituting into a variable, we always put parentheses around the number so that this kind of thing doesn't happen. So this gives me negative 3 over here. This is negative 2 squared minus 4, which gives me 0. 4 minus 4. And then we have negative 3 squared minus 4. Negative 3 squared is positive 9 minus 4 gives me 5. And you can start to see some symmetry here, which is what we're going to talk about in a minute as well. Okay. So let's go ahead and graph this now. Got actual graph paper ready to go this time. So we are going to graph this, and I'm going to set up my graph. I'm going to do it in the most proper way that I can. Okay. So we have our x-coordinates, we have our x-axis, we have our y-axis, we have our scale. We're going up by 1 in both directions. If we really want to, we can continue to label this in both directions. Again, this is above and beyond what you need to do, but this is the best practice for you to do. So we had our coordinates. We can check back here. We had 0, negative 4. So 0, negative 4 is actually right here. Let me do that in a different color so we can see it better. 0, negative 4 is right there. Then we had negative 1 and 1, negative 3. So we had these points here. Then we had 2, 0, and negative 2, 0. Then we had 3, 5, and negative 3, 5. And so just plotting these points, we get a sense of what this function looks like. And it looks like a parabola. And we will talk more about families of functions next time in a future video. And it's important that we start to get an idea of this basic shape. So a basic quadratic starts at the vertex. This is the vertex. Goes up 1, out 1, up 3, out 1. So from here, up 3, out 1. Then up 5, out 1. We will talk about this again, so don't feel like you need to know that right now, but we will hammer that home later. So we want to find x and y intercepts of a graph because these are usually the most important points on a graph. X-intercepts being the most important, y-intercepts being important for word problems where you're looking at for the initial amount. So when t equals 0 is usually my y-intercept because t would be the input instead of x. But if you think about this graphically, it makes a lot of sense. Any point along the x-axis, let's just pick this point right here. I don't care what the x-coordinate is, but what is the y-coordinate? The y-coordinate is 0. And if I pick any other point here, the x-coordinate is something, it's a negative in this case, but the y-coordinate is 0. So anywhere on the x-axis, the y-coordinate is 0. So we can set y equal to 0, and that will lead us to where the x value is, and that will tell us what the x-intercept is. Likewise, on the y-intercept, any point that I pick on the y-intercept has an x-coordinate of 0 and a y-coordinate of something. And so we're going to set x equal to 0 to find y. So let's go ahead and do that here. I'm going to find the x and y-intercepts. So I start with the y-intercept. If I want to find the y-intercept, I'm going to set x equal to 0. So y equals 0 squared minus 0. Notice I'm putting the 0 in parentheses every time I substitute it in for a variable. Minus 2, and that gives me negative 2. So the coordinate on the graph, the y-intercept, is the point 0, negative 2. And I don't even have to label this a y-intercept. I can tell it's a y-intercept because the x-coordinate is 0. If you want to say this is the y-intercept and label it, that's fine. But if you just write down on for the answer the coordinate 0, negative 2, that is perfect. Now going to find the x-intercept, I'm going to set y equal to 0. Y is equal to 0, and we have x squared minus x minus 2. My favorite way to solve a polynomial function is to factor when I can. And hopefully we remember how to factor. In this case, this factors. X and x is the only way to get x squared. And now we're trying to figure out what multiplies to give me negative 2 and adds to give me negative 1. So negative 2 and positive 1 multiplies to give me negative 2 and adds to give me negative 1. And so that means this equals 0. If x plus 1 times x minus 2 equals 0, that means that x plus 1 has to equal 0 or x minus 2 has to equal 0. Because the only way I'm going to get 0 when I multiply two things together is to multiply them. The only way I'm going to get 0 if I multiply two things together is if one of those things is 0. That's how 0 works. So either x plus 1 equals 0, and in that case x equals negative 1. Just subtract 1 from both sides there. Or x minus 2 equals 0, so that means x equals 2. And there are actually two x-intercepts here. I'm going to write down the coordinates. Negative 1, 0 is one of the x-intercepts, and 2, 0 is the other. And again, I don't have to label these x-intercepts, but I can. I don't have to because I can tell they're x-intercepts because of the y-coordinates being 0. All right, we'll pick this up in the next video. I'll see you then.